Good evening, guys. Good evening to everyone. Yeah, good evening. So we'll just wait for another 5 minutes, okay? And then we'll start the session. Okay. Okay, good evening, guys. I hope everyone is here. So, what are we discussing in the last session? What did we discuss in the last session? And I see two people have raised their hand. Slok and also Rishu. Satyam, Yash. What happened? Are you having any doubts? Vivek, Shivam. Fine. Yeah, hello, Vivek. Okay. So, you no, lucky. So, don't try to. I mean, please make sure that you're joining all the sessions, okay? Please try to join all the sessions and don't miss the any other lecture, okay? It is just for 2 hours, right? Okay. So it's fine for now. The line plot and scatter plot, bar chart, pie chart, the types of chart we have discussed and plotting we have done. So and also handouts have been provided. Have you gone through the handouts? Everyone. Have you people gone through the handouts? I have uploaded the handouts also. Okay, fine. Okay. So okay, fine, got it. So Devansh, you'll be getting a recording of those lectures, okay? Don't worry about that. You'll be getting a recording of that lectures and you'll be getting those recordings link update through your Telegram, okay? Please make sure you're joining in your Telegram group. There is a group, okay? Group created. So now we are done with the NumPy, Pandas, Matplotlib, and Seaborn. Correct. So what are the topics left? There were two main topics left. One is statistics. Okay, statistics is the main part which is left, and then the machine learning. I hope that's clear for everyone. So today we will be discussing the types of data. Test also will be discussing t-test, z-test, and f-test. What exactly those are? Okay, we'll discuss all those things today. And let me just share my screen. Just give me a minute. And in the meantime, if anyone is having any other doubt regarding the previous topics, you may post it in the Q&A. I'll just share my screen just a moment. There is no link for recording lectures in the Telegram. Okay. So I'll just inform the team once again to update those link. Okay. Ambuj, the session has already started. If you're having any doubt, let me know. Okay, we are here and we're done with the Python and also data types, control structure, machine learning libraries. These two libraries were done. And later we're done with these applications also, the pandas, visualization we are done, correct, matplotlib and seaborn. Now we are able to enter into the statistics. Okay. What exactly is statistics? What are the different types of statistics we'll be seeing? What is statistics, guys? What it is? What it is saying, branch of mathematics which involves the collecting, analyzing, interpreting the numerical data. So where we will be collect the data, analyze the data, and interpret that same data. Okay. Collect the data. After collecting the data, we'll be analyzing the data and interpreting the data. So that type of process where we do, and that is called as in statistics. And what it is saying, it's used to control large group of people or things. Okay. And what are the different types? It is saying descriptive statistics, inferential statistics. So under the descriptive statistics, what are all the things describing the properties of the sample and the population data? I will explain what is sample and population. Okay. And what are the things under inferential statistics using those properties to test hypothesis testing and draw the conclusion? Descriptive statistics include mean, variance, skewness, kurtosis. And inferential statistics, they include the linear regression analysis also, which is analysis of variance, log it or prob it models, and null hypothesis testing. So it is saying that in the statistics, see, statistics mainly, what exactly statistics is, which involves in collecting, analyzing, and interpreting the numerical data or the data which we are having. That we'll be calling it as statistics. Okay. The different types of statistics, which is a descriptive inferential statistics. Now, exactly how to analyze our data, how to understand what kind of data we are having, we'll see. Okay. Not this exactly. Yeah, types of samplings also we'll go through. Then we'll go through the hypothesis testing, then the Bayes theorem, then the central limit theorem. I hope you people are aware of this Bayes theorem and the central limit theorem, right? Okay. Don't worry, we'll be covering those also. We'll be just okay. Okay, Shivam, are you aware of the statistics? And also one more thing, in between the session, don't keep any queries. Okay. If it is related to the session, then then drop your queries. I mean, whatever the topic which you are discussing on that particular day, then only drop the query. Okay. Then please don't drop any other queries in that case. Okay. Before 10 minutes, the first 10 minutes and the last 10 minutes, you can drop any query and I will be addressing those queries. Okay. But not right now. Okay. Thank you. So I told you types of data, right? What are the different types of data we are having? In the meantime, I'll just open my notepad also. What are the different types of data are we having? Anyone aware types of data? Anyone heard of it? What are different types of data? See, as of now, what we know, we only know two things. Types of data means we know structured data, unstructured data, right? Structured and unstructured data. But let me just share my notepad. We'll discuss few things. We'll discuss about the types of data, sampling, and also we'll discuss about these measures of central tendency, the p-value, hypothesis. Okay? We'll discuss all those things. Let me pull a new tab. Were you able to see the screen? The notepad. Okay. Okay, okay, fine, fine. I'm sharing, that again. I think now you are able to see the screen, right? Okay, fine. So as of what we know, what are all the different types of data are we having? Structured and unstructured data. What is structured data? Structured data means where we'll be having it. It will be in a tabular format, right? Unstructured data means we'll be having images, videos, files, so those kind of data. Correct. So coming into statistics, what happens is we'll be considering the data. What kind of data we'll be considering? We'll be considering what are the different types of data we are having and how to handle what kind of data, how. Okay. How to categorize the data we'll be understanding. Okay. We'll be discussing the types of data as per the statistics. Types of data. I hope everyone able to see. So under the types of data, we have mainly qualitative. Okay. Have you ever heard of this? Qualitative, qualitative data. And we have quantitative data. Okay. Qualitative and quantitative data. So what are these two kinds of data? See, qualitative and quantitative. We're talking about the quantity and we're talking about the quality. Quantitative data means we will be dealing with the numerical data. Okay. Have you ever heard of this, guys? Okay, so I told, right, quantitative means we'll be dealing with the numerical data. So what is qualitative then? What is qualitative data? Okay, category. Correct. You see, yeah, it is talking about the category. Correct. So qualitative data means it will talk about the quality. Means categorical data. Categorical means string or textual format data. And quantitative means it is a numerical data, which talks about the numerical. Numerical is nothing but the numbers again, okay, which includes the numbers, okay. Quantitative is numerical and qualitative is categorical, remember, okay. Okay, let me just write it over here. Qualitative and quantitative data. So what is qualitative again? Qualitative means it deals with the categorical. Categorical data. Categorical data is nothing but it could be either in the string format, string or textual format. Correct, textual format. Okay, fine. So what is this quantitative data? Quantitative is nothing but numerical format data. Correct. It is numerical data. Numerical data in the sense deals with the numbers. Correct. It deals with the numbers. So in this qualitative data and quantitative data, again we are having types. Okay. In this qualitative and quantitative also we are having types. First we'll discuss about qualitative, then we'll discuss about quantitative. In the quantitative, there are two types. What are these two types? Nominal data. Okay. And the other one is ordinal data. Okay. Ordinal data. What is nominal data? In the nominal data, have you ever heard of this nominal data and ordinal data? Okay, fine. So nominal data means there will be no order followed, okay? No order followed. Ordinal data is nothing but the order is followed. Order is. So what is this no order followed or order followed? Yeah. Any examples? Can I get any examples? First, initially, I will just explain for qualitative data. You need to give examples for quantitative, okay? So for qualitative data, nominal data and ordinal data we are having. In the nominal data, one of the example we can consider is gender, where the order doesn't matter or order is not followed. So in the gender, what are all the two different categories we are having? Male, female are the two genders, right? So is there any order? Does it need to follow any order over here? No, right? No order followed. For male and female, is there any order followed? No, correct. But where should be the order followed? The order should be followed when we are dealing with the education level, okay? Education level. So when we are dealing with the education level, the order is like 10, followed by 12, followed by bachelor's, bachelor's. Then we are having masters, correct? Masters, then PhD. See, the order should be followed, correct? So whatever the data which we are having, let's say textual or numerical. So if it is a textual, we will say qualitative. And in the qualitative, we are having both nominal kind of a data, ordinal kind of a data. What is nominal? No order followed. There is no orders, no such order kind of, no such hierarchy kind of thing is followed. Best example is gender. Either the male could stand first, either the female could stand first in the line. So no order is followed. Ordinal data is the order is followed. Whenever you are applying for any job application, the order will be considered. They will consider from bachelor's only. Sometimes they won't be considering the PhD level people. They'll be considering only up to 10, 12 bachelors. So we will not consider PhD. In that case, they are considering the other people. Okay. So understood the difference? Nominal, ordinal. Okay. For nominal, I got an example from Shiva, that is color red, green, blue. Okay. Fine. Okay, for now. Thank you. I hope everyone understood this nominal and ordinal. Now we'll be discussing this quantitative, okay? Quantitative. In the quantitative also, here we will be dealing with the numbers only. But here we are having two types in the quantitative again. One is discrete and one is continuous. Discrete and continuous data. Discrete data and continuous data. What is discrete data? Discrete data is nothing but which can be typically counted, okay? Typically counted. Typically counted. And continuous data is nothing but which will be in a certain range, okay? Which will be in a certain range. So now, typically counted in the sense discrete data. Discrete and continuous comes under quantitative data. Quantitative is numerical data. In this numerical data, we are having discrete and continuous. So discrete will be a numerical kind of a data. So typically counted in the sense we can say, what could be an example for typically counted? One of the example we can consider is number of the cars in the parking lot. Number of cars in the parking lot. So this could be one of the best example. Correct. Number of the cars in the parking lot could be one of the best example because it can be counted. If you can give any other examples, you may drop. Okay. You may drop the other examples also. And certain range in the sense, range, what is range? Just a moment. I'm sorry. So certain range means it will be minimum. Range is nothing but maximum and minimum, right? Max minus min. So certain range, what could be the examples over here for certain range? Could be height, correct? Height, weight. This could be the example for the continuous data. So the types of data, qualitative data, quantitative data. Qualitative deals with the categorical data. Quantitative deals with the numerical data. In the qualitative, we have nominal, ordinal. And nominal means no order is followed. Ordinal means the order is followed. And in the quantitative data, discrete data means typically counted. Continuous data means certain range. Okay, these are the two different types of the data in statistics we deal with. Hope you understood everyone. Any doubts, anyone? Yeah, good evening, Abhijit. I didn't understand your question. So everyone understood, right? What are the different types of data? Qualitative, quantitative, nominal, ordinal, discrete, continuous. Anyone need some other explanation on this? Clear, right? Okay. 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 Got it. You got it. Fine. 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 Okay. So these are the types of the data in the statistics. Okay. In the statistics also there is one more thing. You need to refer to permutations and also combinations. Combinations and permutations. Knowing these two things are very important. Okay. Having a knowledge on permutations and combination is very important. There were a few questions also related to that. You can refer to that. But I hope the types of data is clear for everyone. Then we'll be moving to samples. Okay. Sampling. What are the different types of samples? Okay. We'll discuss the sampling. So what are the different types of samples? So what is the sample? What is the population? Then we'll move to the measures of central tendency. Let me just add it over here. Measures of central tendency also. Not here. I'll just add it over here in the next page. Okay. Tendency. Tendency. So measures of central tendency. To find the central tendency, there are some measures and they are mean. Okay. Mean, and also you can consider median and mode. Okay. Three measures of central tendency you can consider there: mean, median, and mode. Okay. I'll just write here mean, median, and mode. Okay. Fine. So in order to understand the sampling types of samples, you need to know what is sample first. What is population first? You need to know population. So what is population? See, when we are working on any data set, or else when we are working on any problem statement, we'll be having our data, right? Whatever the data which it will be provided by our manager, right? So that data, that whole data set, we'll be calling it as population. Okay. Entire data set or entire data, we'll be calling it as the population. Let me just write here. Entire data or data set, we'll call it as a population. And We'll also have this parameter called sample. What is sample? Sample is nothing but number of the fixed observations. Okay. Or else picking up a specific part of the whole data. Okay. Picking up a specific part of the whole data, the whole population. And in that, how are we considering only few rows? How are we considering only specific data? That comes under the types of the sampling. Okay. First, I will write sample. Number of fixed observations. Okay. Number of fixed observations. Nothing but considering only specific data. Okay. Specific data. Sample is nothing but. So in this sample also, how are we considering this specific data? So consider that specific data. We are having types. Okay. We are having types. So you understood, right? Sample, what exactly sample and population. So for that sample only, there is this term called sampling. Sampling. So what exactly sampling is? Considering the fixed number of observations from the whole data or population. That is considering the fixed number of observations. So considering the fixed observations or else fixed number of observations from the whole population. From the whole population, or what is population again? The entire data set, right? Entire data set. That's it. So if someone says sampling or sample, it both means the same, considering only specific part of the data from the whole data set. But if someone asks you like what is the difference between a population and sample? So population is like whole. So entire data set. Sample is nothing but only few specific data points from that whole data set. Okay, that observations means nothing but here observations is rows and columns. Okay. Let me just write it over here. Rows. Observation are rows. Some will be saying like how many observations are you having? How many in a data set? In the whole data set, when coming into statistics, observations means rows. When coming into data analysis, observation means what are the insights that you are finding. So it depends on the question. It depends on the question format. Okay. Fine. So up to here, it's clear, I guess. The sampling, population, observations, measures of central tendency. Fine. Got it. Yeah. Selecting a subset from the data set. Correct. Okay. Fine. Yeah. Sample and sampling are the same. Sample and sampling are the same. Now coming into types. Okay. Types. The very first type is simple random sampling. And also there is another sampling that is systematic sampling. And also there is another one. See, there were actually around 7 sampling types. Okay. 7 types of samplings. But we will be discussing only the 4 main types. Okay? The 4 main we will be discussing. Not star, it is stratified. Stratified sampling. Also there is another last one that is clustered. Okay. Clustered sampling. Okay. So now what is this simple random sampling? And don't worry, even for these also the handouts will be provided. Okay. Need not to worry about this. So what is this simple random sampling? Simple random sampling is nothing but it will randomly draw the samples from the entire population. Okay. It will randomly draw the samples from the entire population, nothing but the sampling process only, simple random sampling. So we are just randomly drawing the observations from the whole population. So that is what the simple random sampling is. And if you're not entering any term in between, let me know. Okay. So systematic sampling is also the same, but here we'll be randomly drawing the samples at regular intervals. Okay, randomly draw the samples at regular intervals. At regular intervals, we'll be drawing the samples. So, like, let's say the interval time period, interval we are considering, or else the interval threshold we are considering is 10. So, at every 10th person, or else at every 10th observation, we'll be drawing that sample. Got it? So, let's say there is a line of 100 people, there is a line. But every 10th person we'll be considering and we'll be pulling them out. So the person who is standing at 10, 20, 30, 40, 50, 60, 70, so we will be pulling them out. So that is what the systematic sampling is. Okay? That is what the systematic sampling is. And coming into stratified and clustered will be almost similar, but try to understand. So stratified sampling is we'll be drawing the samples from the subgroups. Okay, from the subgroups we'll consider the samples. Okay. So which one do you want me to explain again? Okay, fine. So I'll just complete this stratified clustering and I will just walk you through all these types of data and measures of central tendency. Just a minute. Okay, fine. So stratified sampling is where we'll consider the samples from the subgroups and how the subgroups are formed. The subgroups are formed based on the types of the data which we're having. Okay, based on the data. So let's say we are having a column which is related to categorical data where it is having 2 to 3 classes. So based on those 2 to 3 classes, we'll be dividing our data. That is based on the subgroups only, we'll be considering our data. Then we'll consider the samples from those sub data. Okay. So that is one way. I mean, that is what stratified sampling is. So clustered means you all know dividing the things into groups and you'll consider the samples groups and consider the samples. Got it? So once again, we'll go through the types of samplings. Okay. Simple random sampling. Simple random sampling. The name itself, it is saying we are randomly considering the observations. So randomly drawing the samples from the entire population. Systematic sampling. So what exactly it is saying? Systematically, we are sampling. So at regular intervals, we are randomly drawing the samples. At regular intervals, we are randomly drawing the samples. So if you want me to consider an example, let's say let's consider the same example. I'll just try to explain it, or else you can consider. Yeah, you can consider this. Whenever there is an examination happening in our own on-premises college, or else during our schooling, how exactly the seating order will be? The person who is sitting behind us will be of a different branch or else a different class, correct? And the person behind him will be of our same class, correct? So alternatively, so after me there will be a different person, then after him there will be the person who is related to our class, and similarly after him there will be a different person, and after him there will be the person who is related to us. So alternatively we'll be sitting right, we'll be skipping one bench and we'll be skipping. So at regular intervals, what is the interval over there? 1, correct? So we are leaving one bench and we are sitting, correct? So and so in one room we'll be drawing, if we draw the samples, if let's say in a room we are having 30 benches, if we draw the samples we'll get only 15 samples. In that whole one room population we are having 30, but if we draw the samples and we are considering interval as 1, so we are skipping one person. So in that case we'll get how many samples? 15 samples. I hope I didn't make it more clumsy. Okay, fine. So clear, right, everyone? Fine. So in the stratified sampling, how exactly happens? So first we'll be having our whole data set. Okay, we'll be having our whole data set. Let's say, we are having a, or else not that exactly. Let me just, there is this one of the best example, a survey example for stratified sampling. Okay, I'll just try to explain it over here. So a survey is happening. Okay, a survey is happening in, and they have considered 10 cities for the survey. 10 cities for the survey, or else 10 states you can consider, or else let's consider 10 cities. Okay, 10 cities. For these 10 cities a survey should be happening. For these 10 cities a survey should be happening. So now what exactly happens is, from each 10 cities they will consider only one single major area to get to know about the city. Okay, one single major area to get to know about that city. Instead of going to all the areas in that particular city, they will consider any one single major area to get to know about that particular city. So that is how they are doing the surveying. So here the 10 cities are our whole population, and considering from each and every city one single major area is what the sampling is. Okay, the survey is the whole population and subgroups is 10 cities. Surveying, we have the whole data, and we are having the cities column also over there in the dataset. So in that cities column we are having 10, so we are considering it into subgroups. So 10 cities will have, so from 10 cities we'll consider any one single major area to get to know about that particular city. So we'll draw only one single data point from each and every city to get to know about that particular city. Okay, so that is what the stratified sampling is. Clustered sampling, as you all know, based on the if you have seen any unsupervised learning data, based on the characteristics or relationship which the dataset is having, it will consider to divide it into groups. Okay, it will consider and divide things into groups, and from the groups the samples will be drawn, and how many samples to draw, it will be completely dependent on us. Okay, we'll be deciding that. Clear? Clear, everyone? Any doubts? Shivam, Vijit, and also others. Okay, so voice is there was a lag in my voice. Every day is it the same or else today you're feeling everyone is having the same issue? Is there internet connectivity issue from my side? Yes, only today. Okay, Vivek, I will explain. Okay, not regularly. Today your voice is clear, it is clear. Okay, for few people it's clear, but I say majority are mentioning it's not clear. Fine. Yeah, even my internet is good. Okay, fine. Yes, correct. But you need to have the groups, okay? See, one of the example, see guys, one of the example is given by one of your friend for stratified sampling. So your friend is saying that splitting the whole population by the age group, but here you need to have the age groups, okay? Not see, we'll be under the age column, we'll be having from 0 to 50, let's say. But we need to divide them into groups first. 0 to 10 one group, 10 to 21 group, 20 to 31 group, 30 to 41 group, 40 to 51 one group. And then we can sample each and every data point from each group. So that is what the stratified sampling will be. Okay. Okay. And also, guys, please make sure that even from your end, the connection is good. Okay. Because others were able to hear it clearly. So please make sure from your end there is no such issue. Okay. So that is one of the example for stratified. So similarly, if you consider for this clustered sampling, cluster means based on the relationships or else based on the characteristics, we'll be dividing the things or else our own population into groups. And from the groups, we'll be picking up the data points. Okay. See, for the 10 cities survey population also, you can consider. So if you want to do a clustered sampling, we'll be dividing them into cities. Okay. So after dividing them into not cities exactly, mm, yeah, if there is no other any better column over there or better feature over there, you can consider cities. And on that cities, instead of like in stratified, what we are doing, we are considering one major city, right? So instead of picking one observation from the each city, we'll be considering from those all those 10 cities or from all the 10 groups, we'll be again doing the same thing. But what we are doing over there, we are grouping the things. Whatever all the features of the variable which are present for one group will be in that particular group, so that whatever the observations which are falling in that particular group, it will be related to that particular group only. We'll be just drawing the observation from those groups. It will be almost similar. It will be almost similar. So don't worry, I will try to come up with another example. Okay. I hope it's okay. I mean, have you understood everyone? So I can proceed forward, or else I'll just make sure that everyone is understanding. So these are just the basic things which you need to understand. Okay. There were many notebooks also to work on these types of sampling. I'm having a notebook. I'll just go through that notebook. Okay. I'll just go through that notebook and I will upload that notebook. Okay. The difference between again stratified and also clustered. So you understood what exactly is stratified sampling? Okay, I see a response. Okay, so what did you understand by stratified? Divide the population into subgroups. Subgroups are like for the survey we have considered cities, or else one of the example given by one of your friend was the dividing it into age groups. Correct, and then we will be randomly sampling from them. Correct, and in the clustered population, I mean clustered sampling, what we'll be doing? We will divide the population into clusters. Okay, we'll divide the population into clusters. And randomly we will be selecting a cluster and then sample from those within those clusters. Okay, we'll be picking the samples from that particular cluster only. So let's say I'm having a data set, and in that data set is related to a kind of a survey where it is having a geographical areas, schools, or the household types, okay, or households, let's say. So now what I'll be doing is I'll be dividing it into clusters. Okay, I'll be dividing. I can divide it them. I mean sorry, I can divide the whole population into geographical areas like the city, or else I can divide them into schools. Okay, I can divide them into households, and then I'll randomly select the clusters. Okay, see, dividing them into groups is nothing but considering the clusters, and then randomly select a cluster and then sample within those clusters. Okay, randomly select a cluster and sample within those cluster. Cluster, that means same type of data in the same group or the cluster. Yeah, within the cluster we'll be sampling. Okay, we'll just randomly pick a cluster. We'll be dividing them into groups first. Groups is nothing but the clusters, and from those clusters we'll be considering a random. We'll be randomly picking a cluster, and from that random cluster we'll be considering the samples. Okay, we'll be considering the samples. It will be a bit confusing, but try to understand. Okay, okay, fine. So, what are the things we have discussed today in the first 1 hour? Types of data, qualitative, quantitative. In the qualitative, we are having nominal, ordinal, and for the quantitative, we are having discrete data and the continuous data. Then comes the measures of central tendency, mean, median, and the mode. And we are also having this population. What is population? Entire data set sample or sampling is nothing but considering the fixed number of observations. The types of samplings we are having: simple random, systematic, stratified, and clustered sampling. Correct. Clustered sampling. Fine. Hope you people understood. Fine. So if still anyone is having any doubt, you may ask in the Q&A. In the meantime, others, you can have a short break. Okay. We'll just have a short break for now. Okay. Thank you. Okay. I hope everyone is back from the break, and also I see a few queries. So you have actually missed all previous sessions. So yeah, you can access the recording sessions, but the you need to. I mean, the link needs to be updated. Okay, the link needs to be updated. I'll just inform the team, and I will let you know by tomorrow. Okay, and the links were updated tonight. I will let you know in the Telegram group. Okay. Beside attendance, project attending all the sessions. So that comes under the attendance part. So completing all the given tasks that comes under the project. Okay. Yes, it is necessary. It is necessary to complete the courses and the labs. Okay. And attendance project are the two main mandatory things. Okay. Any other queries, anyone? No, right? We can start the session, right? So now we will be discussing about this hypothesis. And in the hypothesis, we're having null hypothesis and alternate hypothesis. We'll discuss about the p-value, and then we'll go into the Bayes theorem, central limit theorem. Then we'll go for the machine learning life cycle. Okay. Then we'll start the actual machine learning life cycle. Okay, fine. So what is hypothesis testing? And let me just share my screen just a moment. Yes, Piyush. Hello. I hope everyone are able to see the screen. Piyush, have you joined the session just now? No, right? So just now we have discussed about that. Okay. I'll address your query, but not right now. Okay. We'll just start now. Okay. So now we are discussing about hypothesis. Okay. What is this hypothesis? What is hypothesis exactly? First, we'll go through the PPTs, and then we'll come for this explanation. Okay. Share the screen again. Sharing screen. Okay, fine. So types of sampling done. Hypothesis. In the hypothesis, we have null hypothesis, alternate hypothesis, statistics test. Okay, so null hypothesis, what it is saying, statement about the population parameter assumed to be true, which is assumed to be true. And alternate hypothesis, statement that contradicts the null hypothesis. So contradicts is not completely opposite. And statistical test means use it to determine whether to reject or fail the null hypothesis. Correct. Okay, fine. So now we'll see what exactly is this. Is assumption. Assuming that a particular statement is true, right? Or else considering a statement, considering in the sense assuming. So I'll just write what exactly hypothesis is. Assuming a statement which is past is true. Okay, assuming a statement is true or it could be false. Okay, it's nothing but assumption. Correct assumption. So in this hypothesis only we are having null, alternate. Okay, I hope everyone able to see the notepad screen. So initially statement, right? Statement, and under the hypothesis null and alternate. So how exactly null will be denoted as? Null will be denoted as H naught, and alternate will denote it as H A. Okay, H A, H naught and H A. So as per this line, we are stating that assuming a particular statement is good. So now we will assume a statement and we'll write a null hypothesis for it and an alternate hypothesis we'll consider for those two. Okay. Those two we'll be considering, and there is a test called p-value test, which is where the probability will be considered, and there is a threshold value, and based on that we'll either consider our assuming, I mean whatever the statement we are assuming, we'll consider that statement or else we'll reject that particular statement. And how that happens, I'll just tell you. Okay, so we'll just consider a statement first. So we can consider, let's say we are working in a pharma company. Okay, we are working in a pharma company and we have developed a drug. Okay, we have developed a drug, and that particular drug or medicine is working good. Should work good or else working good. That is our assumption. So I'll always, whatever the thing which we are assuming will be the null hypothesis. So what is the statement here? The statement is the medicine is working good. So whatever the statement which we are assuming, it will be always the null hypothesis. Okay, and for the alternate hypothesis, it will be always the contradictory statement. The medicine is not working good. Correct. I hope the difference between alternate and null is clear. So from the data set or else from the pharma medical data, I am saying that I'm assuming that that particular medicine or the drug is working good. So whatever the assumption will come under the null, and the contradictory statement or else the alternate hypothesis will be the complete opposite of it. So now what exactly happens here is there is a concept called p-value. P-value is nothing but the calculating the probability. Calculating the prob. Okay, prob is nothing but the probability. And to calculate this p-value, I mean this p-value test, we'll say p-value test. In this p-value test, we are having a threshold. Okay, we are having a threshold value of 0.05 is the threshold value. Let me just keep it here. So for the p-value, the threshold is 0.05. So what exactly p-value does is, so whatever the statement which you are assuming, for this statement which you are assuming, you will consider some samples. The statement which you are assuming, you will consider some samples, and on that particular samples, you will be doing this probability value test. Okay, you'll do the p-value test, and if the p-value, it will have a threshold as 0.05. So now, if the output of this p-value is less than 0.05, what we'll be doing is, if the p-value output is less than 0.05, what we'll do is we'll reject the null hypothesis. Okay, reject the null hypothesis. Okay, reject the null hypothesis, and if the p-value, and if the same p-value is greater than 0.05, then what we'll do, we will accept the null hypothesis. Okay, clear? See, whatever the statement which we are having, assumption will be our statement. That assumed statement will be always the null. The contradictory or the opposite will be the alternate hypothesis. Then we'll calculate the p-value. P-value is the probability, and in that probability value also we are having a threshold value. Okay, threshold value of which is 0.05, and whatever the probability value, if you are getting the value less than 0.05, then we will reject the null hypothesis. Reject the null hypothesis means, what is the null hypothesis statement here? The medicine is working good. So we are not accepting this particular statement. We will reject this statement. And what we'll do? We will accept this statement. Okay, we'll accept the statement. What statement will accept? We'll accept the alternate hypothesis statement. So reject the null hypothesis here and accept the alternate hypothesis. Okay, and it will be quite opposite over here. If the p-value is greater than 0.05, then accept the null and reject the alternate hypothesis. Okay, reject the alternate hypothesis. So this is a concept of hypothesis testing. Okay, there will be a calculation involved in this, calculating the probability value also. Please go through the calculation, or else in the handouts I'll try to provide. Okay, this is a hypothesis testing. First, a statement will be assumed. Okay, and for that same statement we'll have two different kinds of hypothesis, that is null and also alternate. Null will be the same as the statement which we are assuming, and alternate will be completely opposite. Okay, and then we'll consider the p-value test, the probability value, where the threshold value will be 0.05. So if the p-value is less than 0.05, then we'll reject the null hypothesis. If it is greater than 0.05, we will accept the null hypothesis. Okay, we will accept the null hypothesis over there. There is one more concept. After completing the Bayes theorem and all, we'll discuss about them. Okay? There is one more concept. Currently trying to recall that concept. Okay, we'll discuss about that concept. Okay, I'll just look through the concept name. I'm currently unable to remember the concept name. Fine. So the types of data, measures of central tendency, and also population sample, types of samplings, hypothesis testing. Okay. Then what are we having? Then what are we having? What is left for the discussion? The Bayes theorem and also central limit theorem, right? And also there is this concept called, yeah, I got it now. There is this called type 1 error, type 2 error. Have you ever heard of this type 1 and type 2 error in the statistics? Anyone? Okay, so what's type 1? I see some yes. So what is type 1 and type 2 error, guys? See, no one is answering. Fine. So type 1 error is nothing but a rejecting the true null hypothesis. Okay, true null hypothesis. When we are rejecting the actual null hypothesis, then that is the type 1 error. And type 2 error is nothing but we will fail to reject a false null hypothesis. Okay, false null hypothesis will fail to reject that. You're having it in your engineering mathematics 4. Okay, fine. Type 1, type 2 errors. Fine. Got it. So in that case, you people should be clear with the type 1 and type 2. Correct? if I'm not wrong. Okay, anyway, I'll just write. I know about engineering mathematics, how stressful you people will be feeling sometimes. Just write it over here. So type 1 error, it refers to rejecting a null hypothesis, okay? Rejecting a true null hypo, okay? Rejecting a true null hypo. And what is this type 2? Type 2 is nothing but failing to reject what? Failing to reject a false null hypothesis, okay? Failing to reject a false null hypothesis, okay? So yeah, this is it. And it's 0.05 is nothing but the 5% chance of considering. So if you're saying in the type 1 error, if you are rejecting it by 0.05, so it's like 5% chance of chances of rejecting a true null hypothesis, okay? Do you need any examples over here? Or else everyone is good with type 1 and type 2? Yeah, significance level. Yeah, it is by a significance level. Let me just write here. The significance level will be 5%. And thank you, Jay. Yeah, significance level. And mostly it will be 5%, but depending upon the domain and the type of the problem we are solving, it will be switching, okay? It will be changing. Okay. So I hope everyone is clear. Now what we'll be doing is, instead of going into the Bayes theorem, we'll discuss the statistical test, okay? What are the different types of the test present, okay? I'll write right here. Okay. What do you want me to repeat, Keshav? Keshav. So what are the different types of statistical tests present? Anyone know about t-test? T-test we are having, z-test we are having, and after z-test we have chi-square, okay? Chi-square test we are having, and also we are having f-test, we are having ANOVA test. F-test, ANOVA test, okay? So these are all the different types of statistical tests which we will be performing, okay? And among all this chi-square will only perform on the categorical data. So let me just pull this out and keep it out over here. Name it as phi. So t-test, z-test, f-test, and ANOVA test will be performed on the data type numerical, but chi-square it will be performed on categorical data, okay? Categorical data. And in this, mostly we'll be having the assumptions, we'll be having assumptions, and we'll be having the sample size, and we'll be performing these statistical steps. Okay? I mean the test, whatever the test which we are having. Okay, t-test, r-test, chi-square, it's all in math 4th, second year bachelor's. So if it is all present in your bachelor's, now you people should guide me, okay? What exactly the t-test is? What is the purpose of t-test? Okay. What is the purpose of t-test? Okay. Together, everyone or else someone, let me know what is the purpose of t-test. Okay, I see one person answered. Okay. Yeah, significant difference in the mean of the data. So, what are all the means that you will be considering? You'll consider two different means. What does that mean? One is the sample mean. You'll be considering the sample mean to know the population mean, correct? And what is this t-test called? See, I have asked two different questions at the same time. Just a minute. Sample mean, population mean, if there is statistically of the group. Okay, okay, fine. So first I'll say the purpose. Okay. Then there were also types involved in it. And when to use it, I will say. As per this format, I will explain. Okay. So what exactly t-test, what is its purpose is to compare the mean. Okay, to compare the means. What means? The sample mean and also the population mean. And after comparing, it will be saying if there is any difference. Okay, if there is any difference which are statistically significant. Okay, let me just write here. To compare means and determine if there is any difference, or else if differences are statistically different. If differences are statistically different, so statistically significant. Okay, significant. Sorry, fine. So that is the main purpose of it. And what are the types in this t-test? What is the type? What is the first main type? One sample test, right? One sample t-test. One sample t-test. And what is the other one? Independent two sample and paid t-test. Okay. Independent two sample test and also paid t-test. Okay. Paid t-test. So these are the three different types of the t-test which are present in the t-test. Okay. Okay. One sample, two sample, two sample. It is used for a small sample. Okay, fine. So these are all the answers I have got. So let me just dive into this one sample t-test. What it is? It is nothing but comparing the sample mean to a known population mean. Okay, to a known population mean, we'll be comparing our. We have already known a population mean. We have just considered a sample and we have calculated the mean for that sample. And now we are comparing the sample mean to the population mean. Okay, sample mean to the population mean. So let me just write here. Known population mean. Okay. Okay, fine. So independent two sample test. What it does? Independent two sample test. So the name itself it is saying that it will compare means of two independent groups. Okay, two independent groups. It will compare the means of two independent groups. Compare the mean of two independent groups. What does paid t-test does? Paid t-test will compare the means of the same groups. Okay, so compare the mean of same groups at different times. So what is this compare the mean of same groups at different times? What you can say? What could be the best example for this comparing the mean of same groups at different types? I mean at different times. See, I'll say one example for paid t-test, okay? See, let's say I'm having a mark sheet of a class, okay? I'm having a mark sheet of a class before attending a particular workshop. And when they are done with that particular workshop and they were done with the examination, I will have another mark sheet, right? I will have another mark sheet. So when I'm considering the average of this mark sheet and that mark sheet, okay, what I'm doing over there, I'm comparing the average over there. I mean, I'll be checking the average, right? Average performance of the student before attending that particular session and after attending that particular session. So what I'm doing for the same person, I'm comparing the average of that same person at two different times before attending that particular session and after attending that particular session. So that is one of the example you can consider for a paid t-test. Okay, paid t-test. That is one of the example you can consider. And in this t-test, okay, screen frozen. No, I'm explaining. Okay, I mean I'm moving my cursor also in between to make sure everything is visible. And what is the main formula for this? It will be x cap minus mu. Correct. X cap minus mu by s into under root of n. Correct. So I won't be able to write the formula over here. But what are the main important variables over here? One of the main important variable is x cap, right? X cap. So what does x cap mean? Sample mean. Mu means the population mean. S means the sample standard deviation also. We'll have the standard deviation also we'll have. And also small n. Small n is for sample size, okay? We'll have all these parameters which have been involved in the t-test, okay? So what exactly t-test is? It is used to compare the mean of two different, and then if differences are statistically significant, we will be determining them. Correct. So what are those types? One sample t-test. One sample t-test is nothing but comparing the sample mean to a known population mean. We have already known a average of monthly average of any grocery store which is performing the same. So even from that whole monthly grocery store, we were having a sample store over there, and we have calculated the monthly mean of that particular store. So then we are comparing monthly mean of that particular store to a operating already known average sample, already known population sample. Yeah, degree of freedom is also a important variable or the factor over here. We'll have probability mass function. Okay, independent two samples comparing the mean of two independent groups again. And paid t-test, I have given an example of performance before attending an event and after attending the event. Correct. So that is t-test, right? That is t-test. So now what is the other test? What is the other test we're having? We're having z-test, chi-square, f-test, and also we're having ANOVA, right? So do you want me to discuss all those things right now, or else are you planning to write a quiz? I'm actually planning to conduct a quiz. Let me just do one thing. I'll just conduct a quiz, short quiz for whatever the topics we have discussed until now, okay? And tomorrow we'll start with the remaining types of test. Then we'll go with the Bayes theorem, central limit theorem, and we'll close this statistics and we'll start the machine learning workflow, okay? To start with the machine learning workflow. I mean the life cycle I'm saying. So is that clear, guys? Is that clear? Okay. Thank you. Thank you. Let me just stop my screen share. I'll just prepare a short quiz. Only few questions. Okay. Just a minute. No, class is not yet finished. I just created a quiz, okay? So please everyone scan the QR or else you can enter the code. You can enter that code also. Okay. I just need to re-edit that particular code. Yes, that is the code. Okay. I have pasted it twice. So the code is 199782. Okay. Kanishka, I have already answered that query. We were in the session at around 7:13 or 7:15. I have already answered that. Both are important. Okay. So join the quiz. I'll start the quiz in another 2 minutes. Okay. Piyush. The joining code. Let's provide the link and code once again. Okay. Yeah. It's 1997 and 82. Okay. That is the joining code. Yes, yes. The code is on the screen only. You can sign in with any email, okay? Any email is fine. See, when I am displaying the QR and telling you people to complete the quiz or else join the quiz, any email is fine. But if it is a Google form or else a link which has been shared with you through the email, then you need to do with your registered email, okay? Can I just start the quiz, okay? We are having only 8 minutes of time. I'll just start the quiz. And don't worry, this is not a graded, okay? This is just for practice purpose. Okay, do you guys need some extra time? I see everyone is done. Done, right, everyone? Is the quiz done, or else do you need some extra time? So we'll just wait for another more 5 minutes, okay? Okay, see everyone is done. So we'll close in 5 minutes. We'll end the session in 5 minutes. I'll just give 3 minutes for the quiz, okay? Next 3 minutes is for quiz, okay? Fine. Okay, we'll end this. We'll end the quiz and also this session, okay? Thank you. So let me just end this. Okay. Thank you. Fine. So I hope you people understood today's session. If anyone is having any doubts, you may post it in the Telegram group. Okay. Or else you may ask me in the tomorrow's session also. Now you may leave the session, guys. Thank you. Thanks for attending. Thank you. Thank you. Thank you.